Back in the day, there was this mathematician. His name was Heron. Okay, I kind of started talking a little bit about this guy. So there was this mathematician, Heron. He was really a smart guy, but nobody knows who he is. So he must have also had a absolute major, hatred of the law of cosines, because, like, when you start doing and give you like angle side angle, do you have enough information to find the area? No, but you can start solving it just using the law of cosines, right? Or sorry, law of sines, until you have enough, until you have the side angle side. Same thing with this. Angle side. Same thing with this, and yes, of course, yes, there could be two solutions, and two different solutions have two different areas. Sorry, it's just what it is. Side angle side, you don't have to solve it all because you have all the information you need, right? What's the only potential sucky problem? Side, right? So that one is kind of sucky because you would have to use the law of cosines to find an angle first, right? And then you could use the area formulas. Well, this guy named Heron, he had such a hatred of the law of cosines, because everybody likes the law of sines. It's easy to use, butterfly, law of cosines. He's like, I just hate this. So he spent like years developing this formula that works beautifully. Like, it's a really nice formula. But what is the only use of it? It's to find the area of an oblique triangle if you're given side. That's the only time you're ever going to use it. Why does everybody know Pythagoras and the Pythagorean theorem? Because the Pythagorean theorem is a really useful formula, isn't it? Like, it has lots of applications. His formula, while it works beautifully, it's a very specialized formula. What's the only time anyone would ever want to use it? Is if you're given a triangle and you know side. That's the one and only formula. That's the only one and only use of this formula. If you know any of the other cases, the other formulas are just better ways to do things. So now, his formula is really nice though. So here's the formula. Area equals. It is the square root of. I know, it's a big square root symbol. You ready? S times S minus A times S minus B times S minus C. This is Heron's formula. And there should be one question going through everybody's mind right now. What the heck is S? Like, I know what side A is, I know what side B is, I know what side C is, but what the heck is this S thing? So S is what we call the semi-perimeter. What's the prefix semi mean? Not just partial of, half of. So what's the semi-perimeter? It's half the perimeter. So here's how easy this is to find the area of this triangle. Step 1, find S. Well, what's 14 plus 16? 30 plus 20, 50. 50 divided by 2 is 25. So then, what we would have to find, the area of this triangle will be 25. Don't forget the 25. Times, what's 25 minus 20? 5. Times, what's 25 minus 16? 9. Well, Pause for dramatic effect there. And what's 25 minus 14? 11. That's it. That's all you do. So the next step is you grab your calculator and you just type in the square root of 25. Everybody always forgets to put the s in there. They only do the 3 minus ones. Don't forget the s. Times the s minus each of the 3 sides. And it doesn't matter about the order at all. All you do is multiply those 4 numbers together. Bingo, bango, there's the area of said triangle. You done. Yes?
So you multiply like the 5, 9, 11, and then subtract that from 25? Or you subtract them separately?
So you add them all up, divide by 2. That's your s. So then that's the 25. Then you just take the 25 and subtract each of the 3 sides. 25 minus 20, 25 minus 16, and 25 minus 14. That's it. So if I gave you and 16 and said find the area of said triangle. Well, step 1, find s. What's 18 plus 16? What's 10 plus 8 plus 16? What is it? What's 18 plus 16? 34. Half of 34 is? 17. Now, worst case scenario, the only problem that ever really arises, I just picked 2 problems that add up to be even numbers, which when I divide by 2, I get a nice number. Sometimes they add up to be odd numbers. So what's the worst case scenario? The s is going to have a 0.5, a decimal attached to it. But again, all you now do is you take the square root of the s and then take the s and subtract each side. 17 minus 8 and 17 minus 16. Most of the time you can do the subtraction in your head. Yes, sometimes, you know, the numbers might be big, the numbers might be ugly, and you may want to type this whole thing into a calculator kind of thing. This problem I definitely would not. I would just type in 17 times 7 times, you guys are not doing arithmetic today, times, I'm not even going to worry about the 1, right? I'm just going to type in square root of 17 times, oops, not divided by, times 7 times 9. I'm not going to worry about the 1. And the area of said triangle is 32.7. Is the Heron's formula nice? Yeah, it's pretty. It works beautifully. Why does nobody know who Heron is, though? Is it a formula that you're probably going to use 100,000 times in your lifetime? Probably not. It's probably going to be, you know, once or twice in your lifetime you use this formula. It's a nice formula. It works really well. Heron must have just had a major problem with the law of cosines, because could I solve this problem a different way? Yeah, I could use the law of cosines, find an angle, and then use one of the other area formulas, and it would work just fine as well. But his formula is faster, a little bit easier. What his formula also is a really nice use of now, let's say I want to find that height. Let's say I want to find that altitude right there. That goes to the 16, right? Is it easy to find the area? What is the basic formula for area of a triangle? Area equals 1/2 base times height. So what I could now do is use that formula, 1/2 base times height. I know the area now. Like I use Heron's formula to find the area. That's 32.7 equals 1/2 times, if this is the height that I want to find, which side is my base? 16. How would I solve that for h? I know what I would do. I would just divide that 32.7 by 8. And I'm done. So it's also becomes a really useful way, kind of a backwards approach, to find the altitude of a side-side-side scenario. So if the only goal is actually to find the altitude, kind of a backwards approach is find the area first. Because it's actually really easy now to find the area. Then use the original area formula, area equals 1/2 base times height, to find that altitude. Does that kind of make sense? That's it, guys. That's the whole thing. Huh? So, you guys like Heron's formula? Should we take a quiz tomorrow?
Yeah.
All right, sounds good. Quiz tomorrow. What's the only thing going to be on this quiz? Area of a triangle. Any case is up for grabs. If you get a side-side-side formula, if you get a side-side-side problem, you could use Heron's. Do you have to use Heron's? No, you could use law of cosines and one of the other area formulas. But if you like Heron's formula, use Heron's formula. Easy enough?